We're going to talk about bits and vector and raster information. A bit is the smallest unit of information that a computer can store. The word comes from combining binary digit together. All computers, as you know, use a binary system. They only understand zeros and ones. The 0 and 1 can also equate to black and white or on and off. When you talk about 8-bit graphics, think about the fact that there are 8 different switches that you can combine with ones and zeros to get different kinds of grayscale information. 8 bits of information equals a byte. An example of what a byte might look like is shown here. It takes at least 1 byte to make 1 character. There are some magic numbers when we talk about computers, and 8 is one of them, as is 256. 256 comes from 2, which is black and white, off and on, 1 and 0, to the 8th power, where you have those different 8 switches, and it gives you 256 possible combinations of shades. And those shades are of gray or black and white. If you're talking about 8-bit color graphics, we're talking about RGB. So if we take 2 to the 8th power, we get 256 possible combinations of shades for each of the 3 colors. So now we have 256 times 256 times 256. I know this sounds a lot like math, and we don't do math very well. Luckily, I've done it for you here. But it comes out to 16.8 million colors. Now that sounds like a lot of color, but it's really not. If you're dealing with 16-bit color, which is the equivalent of camera raw, if you're using a digital camera to take pictures, it's 2 to the 16th power. And that gives you 65,536 possible combinations of shades, which comes out to 281 trillion colors. This slide shows you a chart where you have down here the 16.8 million in this little tiny box, and this shows you the 281 trillion. Now, we all know we can't see 281 trillion different colors. We can't possibly see that much. In fact, we can't really even see 16.8 million colors. But if you're talking about, let's talk about crayons in terms of crayons, okay? If you want to win the coloring contest, as some of you have heard Rick talk about, do you want to use the 8 box of crayons, or do you want to have the 64 box of crayons with magic pencil sharpener to pick the best colors that you're going to reproduce to give you your image? Raster, the simple definition is raster equals pixels, okay? And we're going to talk about resolution at another time. But for right now, let's just talk about the pixels in a raster file. A pixel is a picture element, and it's the smallest amount of displayable data. Now, a bit was the smallest amount that it can understand. The smallest it can display is a pixel. The pixel has size when it's born. When that pixel is developed either from your camera when you take a picture, your file when you scan something, or when Photoshop, when you go in and say, I want to create something new, you define the pixels. And resolution is all about how many pixels and how big are they. Okay? The quality of a raster graphic is going to depend on the quality of those pixels. An image that is raster is resolution dependent. That resolution, like I said, is determined when the file is first created. Now, if you look at this example, if you had 2 by 2 pixels versus 8 by 8 pixels, and I said, I want you to draw the letter O, and you can't have part of a pixel, so you have to color in the whole pixel. The only thing you could do is color in all 4 of these and make it solid. Here, you could get a little bit better. As it increases, you can see you can start to get better edges. The smaller the pixel and the more pixels there are, the better definition you're going to have. This is a picture of my grandson when he was quite small, and it's at 300 ppi. This is zoomed in at 300 ppi, so you can actually see the pixels in his eyeball. Now, there are enough pixels, and they are small enough that they do not look pixelized. This looks very clear for this image until you zoom way in. This is a black circle that's been drawn in Photoshop. But if we zoom in on it, you can see this kind of, they call it a rake down the edge, and where it's come in and it's created different levels of gray on that edge to give the illusion of round. Remember, you can't have part of a pixel. So this is making you think that it's round. It's another optical illusion. This, putting these grayscales in here to fake you out and putting these other colors in there, that's called anti-aliasing. Now, vector is very different. Vector is math. It comes from algorithms. It's what you call an object-oriented. A vector program, as you know, is Illustrator, and it's resolution independent. In other words, the object that you're working with in Illustrator doesn't have any resolution until you go to print it. And when you print it, it has to become rasterized or put into pixels so that it can actually output. And then it has the output resolution that you determine. One way to look at it is vector graphics are virtual. They don't really exist until you finally say, okay, I'm committing to this, and you output. That's why they're scalable. If you look at an example here where we have a circle, it's a solid black circle, and on the left you see the circle, on the right you see the wireframe for the circle, and you can see the anchor points that create the circle. The only data in this object is stored in the stacks. And that data says, draw another arc from this stack to this stack at whatever degree angle, blah, blah, that you're going to say. And it's all about the mathematical algorithms. Now, because it's got a fill, if I were in Illustrator and I were to click right here or right here on this circle, it would select the circle because it's filled with black and we are not in wireframe mode here. We can see the black, so we can select the black. However, if you have an empty circle with a black stroke, in other words, there's no fill, this wireframe looks identical to the other one. But if I click anywhere in here, unless I happen to get the very middle point, but if I were to click here, nothing's going to be selected because there's nothing there. Hopefully that makes a little bit of sense. Now, vector graphics traditionally are much smaller than raster graphics. Smaller by a lot. This is a butterfly that's drawn in Illustrator and saved, and you can see it's 394K. Here's the wireframe of that butterfly. The same butterfly opened in Photoshop and saved as a TIFF is 17.4 megabytes. You can see there's a dramatic difference in the size of the file. Now, size of the file doesn't really hurt us like it used to. We used to have to care a lot about how big files were when we only had floppy disk or even you know, some sort of a smaller remote disk to transfer our files. Now storage is cheap, so we can have files be as big as we need them to be. But what you want to keep in mind is the butterfly on the left could be a butterfly on a billboard. It would still be 394K, and it would be smooth as can be because it's scalable. This butterfly, this TIFF, is only going to look good at this size. If we were to take this up really large, the pixels, because the pixels, remember, resolution is how big, as we enlarge those pixels, you start to see that weird stair-stepped edge around the outside of your image, and it isn't going to look nice and smooth. So if you have something that you want to be able to scale from a pencil to a billboard, like a logo, you aren't going to use Photoshop to draw it, ever. Okay? You want to make sure that you understand when to use vector and when to use raster.